Welcome back, everybody. This is our webinar, Saving Money in Operations. How we believe in saving money in operations is through knowledge. I've always told my dad, or my dad always told me that he can tell me a way of doing something and pretty well 15 things of wrong way of doing it. Mostly is from his experience over the years getting into it. Well, this webinar, we're specifically focusing on amine, glycol, and coalescing filtration. That was a big key takeaway from our subject matter expert, Terry Nelson, in the glycol systems. And it's a thing for maintaining our rental fleet, our equipment out there. So we really wanted to share that information. So to get started, to stay in the know for our systems, if you're new to Zoom, there is a Q&A section that you can pop up, ask any question throughout the presentation. We do have a Q&A section at the end. We will try to answer as best we can through the presentation. Now, if something goes wrong, and a lot of us are working from home, India, UK, there might be something that goes wrong. This webinar will be posted up to our blog and our YouTube channel. Afterwards, if you need a PDH credit, I'll remind you again at the end, just let us know. We can ship you a professional development hour credit going on. Now, we are trying something new this time. We have a poll that we opened up. If y'all can have time while you're going through it, answer that poll. So just try it out. I wanted to change it up a little bit. Now, my name is Cameron Croft. I'm the CEO of Croft Production Systems. I've worked for Croft Production Systems. Yesterday was actually my 14th year working here. Chris is our Director of Engineering. He actually started out with me in our engineering degree program. He's worked himself up from mechanical engineer. Now he does all the troubleshooting with the service team, design work, and he runs his own engineering team with Croft Production Systems. So the topic highlights, we really wanted to focus on that, what we thought people for filters and trying to fill in that knowledge gap. So we went from all the way to the basics, basic terminology, and trying to get into more and more depth. And then kind of the case studies, the lessons learned that we've learned over the years with proper filtration. So that's today's outline. Now, starting us off, why use a filter? So Chris, I know this is a basic question, but try to hit that foundation and build this house up. So why would you use a filter?
So filters will give you better separation than a traditional scrubber separator. Usually a scrubber separator, the mist pad or the vein pack will get you like a 10 microns worth of separation of aerosols or particles. So to get below that 10 micron, you're going to need a filter to be able to do that for gas service. And then for liquids, just filters are super important to making sure that things stay maintenance and trouble free.
Well, so it's pretty well ridding yourself of these contaminants. We broke it up into three major areas: solids, semi-solids, and other contaminants. But if you can kind of elaborate, what are those three categories? Why do we break it up like that?
Yeah, so the particulates and liquids are what you want to get rid of first, and filters are really good ways of getting rid of the smaller the particulates that may float through the gas and carry through. They may not stick or fall in the liquid, and they also get rid of some of the aerosols and mists that are going through there. But there's different kinds of contaminants that you may see. You have your solids, which is like your sand or your dry rust particles. You also have your semi-solids, which are more like, they can be solids that are stuck in a liquid that make it a lot more viscous, a lot thicker. It's where you get like your sludges or your slimes that may stick.
Paraffins and stuff?
Yeah, paraffin is a wax, because paraffin's a tricky one because it can be a solid or a liquid depending on the temperatures that you're in. So it can end up in different forms in different areas. And then other contaminants can be like your foams, which are kind of like your weird phase items. And some of the weirder chemicals that may be out there that you want to remove before it gets into your processing equipment. And the reason we want to take it out first is we don't want it to get into the downstream processing equipment where it'll get picked up and cause damage in that more expensive equipment.
So I know you design glycol systems, amine plants. So after this, you really want to kind of focus on the common issues just to kind of hit home the solids, semi-solids, other contaminants. So the first one that you have for a common issue was hydrocarbons. So explain to us, why this is a common issue.
Yeah, so hydrocarbons, that's going to be your non-methane type stuff, your heavier hydrocarbons that may be coming through your gas stream and they end up in that processing equipment. So hydrocarbons are probably your most common issue that you may have, especially if you have a richer gas that's coming in through the system. Hydrocarbons, if you're not separating them out properly, either you have undersized or improperly sized separation equipment. It may make its way in there, and with like a glycol unit or an amine plant, you're basically liquid washing that gas stream, and so it makes it very easy for it to pull things out of that gas stream, and it'll just take it to the regeneration side. Hydrocarbons, you can have a lot of them, especially if you have like a liquid carryover, a lot of condensate. They can come into your system. That can very quickly cause a big problem with your system. So making sure that you're keeping an eye out for those is probably your biggest issue you're going to run into.
So that's hydrocarbons. We got three more common issues. The second one is sludge. So yeah, kind of go into what is a sludge, what kind of makes a sludge, and then how would you remove it?
So sludges can form pretty much anywhere in your production stream. If you have low spots with liquids, you may get some weird sludges that form due to production chemicals or particulates. But within a glycol or an amine unit, the sludges may form due to the combination of the heat and the temperatures and the different contaminants that may be ending up in that liquid.
Mm-hmm.
So the sludges are pretty tricky. They can often be sticky. They can change their parameters depending on the temperatures. They may be soluble at a high temperature, and so they don't show up in a reboiler, and then they carry through and they cool off in a heat exchanger, and all of a sudden they stick to the walls of everything. So sludges are tricky and can form due to various reasons. They can be a degradation product of the amine or glycol. If you heat it up too much, it may overcook it and then become a problem. But good filtration is really essential to making sure sludge doesn't form and doesn't end up in places where it's not supposed to.
Yeah, because it kind of what Terry was talking about on the glycol system. It does a lot on the absorber trays. It starts getting into the heated areas, and then you start losing that heat transfer, right?
Yeah, it can really affect your heat exchangers if it's collecting in there, and then really if it's building up a low spot and all of a sudden slugs into a pump, it can really damage a pump. And pump rebuilds are going to be one of your higher cost items for your standard maintenance on a properly working amine or glycol system. Rebuilding an amine pump is very expensive. Glycol pumps, they're a little cheaper because they're usually smaller, but it's no fun to pull those out, especially the bigger ones. It's just not a fun day.
Well, your third common issue, I think this is I know it's common, but this seems to happen a lot. It seems like you're getting a lot of troubleshooting tickets, mostly for the foaming. And
yeah, so foaming is usually caused in an amine or glycol system either mechanically or chemically. So mechanical foaming is going to be like particulates that get in there, and just the action of like going through a bubble tray or some sort of tray tower, you're going to get that agitation that creates more foaming just from the mechanical side. That usually breaks away pretty quick. It can be a problem if you have a lot of particulates in there. It can help to carry some of those particulates into other areas you don't want them. But the big issue with foaming is the chemical foaming. So that's like if you get a surfactant or something or some hydrocarbons into the system, they can create foaming of your glycol, your amine, and that can very quickly cause a big upset, either carryovers out of your tower or out of your still column. And so minimizing foaming is very important. And typically the more extreme cases, it's going to be a chemical problem, like a surfactant carried through like a compressor lube oil, or the actual lube oils themselves can cause problems, hydrocarbons, or some sort of production chemical that may be getting into the system causing that.
Yeah, that's it. And so from the common issues, we really wanted to focus on proper filter choice. The only way you can utilize that is by kind of dissecting what is actually needed. So the first one you broke up, we got two different designs. We got gas and then we got liquid. So the first one you're looking at is gas application design. So walk us through, if you had someone coming to you, what would you look for?
Yeah, so the first thing you want to know is what the contaminant is you're trying to remove. So even if you have an existing filter vessel, there is different options for the filter types that can go in there, and those can benefit you in different ways depending on what you're trying to remove. So knowing the contaminant, so if you have a dry gas application and you have an iron sulfide issue like a black powder or something, there's a filter that's going to work better for that than something that'll coalesce NGLs out of the system, or something that'll go for like compressor lube oils. Like there's some different ones. So knowing the contaminant you want to remove is number one, because that'll kind of give you the type of filter you're looking for. Then you want to know your maximum flow and your minimum operating pressure, because we're looking for like superficial velocity through that system, so that we know how to max or correctly size for that application. And then the temperature is going to give you some material choice restrictions depending on the higher temperatures. And then the gas composition to make sure that the materials are compatible with what you're doing and to get the specific gravity of the gas.
Well, so that's 5 things that you would look for. So first time someone would ask you for, I need a filter for this, you would start breaking it down by this. This is what's required.
Yeah. From there, we can pretty much get everything we need for a quote.
Okay. The second set was liquid application design, because there is a few things that are different for a liquid application. So yeah, tell us the differences in this.
So number one, you still want to know the contaminant that you're trying to remove. You're going to need to know the maximum flow of the liquid. Pressure doesn't really play an effect on it, but you are going to need to know the viscosity of it, because that's going to affect the mesh of the filter and the density of it that you can get away with. Composition to tell you things like specific gravity and the different contaminants, chemical compatibilities, and then again the operating temperature is important. So liquid design, you get a lot more options with those, a lot more different manufacturers for liquid design. If you're stuck with a certain type of vessel, those can be more difficult to retrofit if you're trying to change a filter. But for brand new design, this is kind of like the base level. With this, you can pretty much size a filter or what the vendor will be asking you for.
That's good. And then, so from those 2 things, it can help you start dissecting, breaking it down to what you're looking for. But this is something that you're definitely wanting to share with everybody, is materials of construction, because we've seen a lot of failures out in the field, and you always ask, like, what is the base product? You get the part number, then you start kind of doing your back end stuff. So materials of construction, you have it broken up into 3 areas. So tell us those 3 areas and why.
Yeah, so materials of construction are going to be dictated by these 3 things. So first off, temperature. So not all materials can handle different temperatures. Certain things like the man-made chemicals, like your plastic type filters, those are obviously not going to be able to handle some higher temperatures on some of those. Things like cellulose, the way that they bind those fibers together, they can't always handle higher temperatures. The length of service, that goes to how long you want that filter to last. Now, ideally, they're going to last, as long as you can get them to. But you're going to, there's a cost trade-off with that. A cheaper filter may not last as long, but if it's a quarter of the price, the more expensive one, then maybe it's worth it, depending on how hard it is to change that filter.
Mm-hmm.
So depending on what's acceptable for length of service can kind of dictate the material choice. And then chemical compatibility is going to be your big one, because the last thing you want is the filter to dissolve that you're trying to use. And not all filters can be swapped between like a glycol or an amine. So knowing that, what is compatible is very important.
Yeah, we got filters out in 14 states. As a CEO, when I'm looking at how many times our service guys are having to hit everything, the length of service was a big thing for us to go every 4 days to 21 days before a filter change out. And I know we had to keep playing for each one, but it takes a lot of effort. But once you kind of get in the rhythm of what works, what doesn't work, I know it saved us a lot of operational cost on the back end.
And like on our little amine plant, like the filter takes 4 string wounds, the case for it, which is way overkill for what the circulation rate of that plant is. But it means we can definitely last a month before having to change that out. And so for us, it was a trade-off that we're like, okay, we'll spend a little bit more on this one vessel, which isn't much over the whole life of the thing. And, we'll get a much longer runtime, safer runtime, because you get a slug of iron sulfide into an amine system, you're going to plug your filters pretty quick. Yeah. So having that extra little, bulk there is definitely helpful.
Looking at that OPEX, it kills you every month looking at it. So yeah, it's good. All right. So the next set, you're really wanting to focus into we're not going to touch all the media materials, but we were wanting to hit the big one. So the first one you have is cotton. So kind of run through what that is.
So cotton is a very popular filter choice. There's cellulose as well. We don't use it. Cellulose filters are the very cheap option.
It's paper, right?
Yeah, they use paper type material. They can be used for a lot of different stuff. A lot of people spec them in, but cotton is really kind of like a really good base level choice for amines and glycol units. The cotton does need to be a virgin cotton, not a recycled cotton, because you don't know what you're getting with that. And then you definitely can't have any of the cottonseed oil on the cotton, or else that oil can create foaming problems or other issues. But cotton is a pretty good one. You know, your most common things you're going to see are like your string wound filters. Those are usually cotton string. But they make different designs, but then they have pleated cotton designs. Like this particular one, it's a sock covered pleated design, so it has good dirt holding capacity over like compared to like a string wound. But cotton is really good because it does have a higher temperature that it can be used for, and there's no chemical compatibility issues with amines or glycols. But you do have to make sure you check to make sure that it is made for that service. It's not a cheaper grade or something that hasn't had all the oils removed or might be recycled with, you know, old T-shirts in it or something.
I guess our procurements, do you call the manufacturer and say, I need virgin oil cotton filter? I mean, is there a way to understand that there's no cottonseed oil in it?
So it's always good to check a spec sheet. You know, talking to the manufacturers just to double check, especially if you are trying to find equivalent replacements. So if you're going from brand A and you want to swap to brand B because it's cheaper, it really is good to talk to the manufacturer. Maybe not so much the vendor that's selling you the filters, but the actual manufacturer, just to make sure that it is a drop-in replacement. Because, you know, it may be cheaper for a reason. Not always, you know, on a manufacturing level, you may be identical filters, you know, some brands, it's just branding that you're paying for. But it is good to double check to make sure that it is meant for that service, because some lower grade filters may look exactly the same, but they're not quite made to the same tolerances, and that can be pretty important, especially on the amine or glycol. I mean, it's some things that falls apart and ends up down the piping. That can be a huge headache with a lot of downtime if it fails.
Well, their second set was polypropylene, so that's a mouthful. But go into it. What polypropylene is?
So polypropylene, it's a plastic-based material. It is the go-to use for water. So if you're filtering out water, so if you have produced water you're trying to clean up for either recycle use or use another, clean it up enough for a frac or drilling mud or something, you know, polypropylene is used a lot for water cleanup. Polypropylene is also a good choice for amine. If it's made properly for an amine filter, it can be used for that as well. The temperature ratings aren't quite as good, especially with the amine temperatures you might see. It may not be a great option, but it is a really good filtering option if it is within that temperature window for you. And you can see the effects of, you know, good filtration on you know, how it just can remove all the solids out of it.
Well, the third media material is fiberglass. So kind of go into, I guess, what the difference between fiberglass and polypropylene would be.
So fiberglass, it is made differently. It is a really good use, and this is what you're most commonly going to see for your lower grade coalescing filters. So like the standard coalescing filters that are used all through the industry, or your filter separator type filters, a lot of those are fiberglass. It is great for hydrocarbons because there's no reactions to hydrocarbons or oils, but they can be have an issue if you're getting amines or other high pH fluids in them. So fiberglass filters aren't really a great choice if you're trying to recover, like let's say you have off of a contact tower of an amine plant and you're trying to reduce some amine losses and your scrubber's not quite up to it. So you drop a coalescing filter after the amine plant tower. You know, it's a good option to try to recover that. You just got to be careful with your filter choice, because fiberglass may not be the best choice to coalesce that and try to recover those liquids. But fiberglass media is a really good choice for coalescing filters. It's you know, a good cost-effective choice, especially if your efficiencies, you don't need super high effective filters, and it's usually what you see for coalescing filters.
Well, and also I'm trying to remember, it handles high temperatures like 300 to 400 degrees. I mean, so on the high temperature range, it's probably the best one if you have temperature issues.
Yeah, which will make them really good for like compressor discharge filters. So if you're trying to coalesce after compressor discharge, yeah. Maybe not so much if you're trying to get out the really hard to remove compressor lube oils, but for coalescing after a compressor, if you got really rich gas, fiberglass is a good choice.
All right, and then our last one was polyester. So explain, polyester, you know, is it a good fit in degrees?
So it is a good fit for glycol systems. It's got a higher temperature rating typically than a polypropylene will. It is good. You know, there is some benefits to these plastic type materials because they are going to be physically stronger than like a cotton or something. The fibers, the polyester can hold together. It can handle a little higher differential across it, which means it can have a little better dirt loading. So you can get away with thinner, physically less material used in that filter and get the same micron rating and effectiveness out of it. So built right, these are, you know, it can be a really good option because of the good chemical compatibility, and the, you know, built into a good shaped filter can be really effective to kind of get you a longer of the service length than just a typical string wound. And string wound can get surface loaded with a bunch of junk, whereas like a good pleated filter can handle a lot more capacity with the same shape and size filter.
Yeah. Well, I know this last one is Gasket Choice. So the Gasket Choice is mostly for the filter housings because we're, you know, swapping the filters in and out, making sure you have a proper seal. And I know we wanted to put this in there because we've learned our lessons. We found the 15 reasons why not to do certain things because things disintegrated, chemical compatibility. But explain, if you can, go into these three major choices and, you know, the differences of them.
So the gaskets, when we're talking about these, they're show up in two places: physically on the filter, and then sealing the filter housing. So it's kind of the same issue, but you want to make sure that those gasket materials are the proper choice. So Buna is going to be a real common filter gasket material. Either, you know, Buna O-rings for the filter vessel heads, or Buna gaskets on the ends of the filters to seal them within the vessel. But it is not a good choice for amine. So it does have certain chemical compatibility issues. For glycol and hydrocarbons, it's fine, and, you know, it's going to work great for that. You may see some swelling, like I know on some of our vessels that have those closures. Sometimes we have to leave them out in the sun to get the O-ring to shrink, because it'll pop out of its groove, and so we got to like kind of cook some of the hydrocarbons out of there because they will absorb them sometimes. Viton is satisfactory for amine, but it still will degrade over time. And it can get expensive on trying to make bigger custom filters or gaskets. But it needs to be minimally Viton if you do have amine server or amine plant. Buna will liquefy in amine. So like if you put a filter with Buna gaskets in, you pull it out, it'll just be a gooey mess.
We learned that the hard way, right?
Yeah, when we weren't checking what the vendor sent us and had the wrong gaskets on the end of the filter. What happens is if the gasket goes away, you get bypassing past the filter's not doing its job, and you wonder why the differential never goes up. But for amine service, Teflon is the best. So like on our little amine plants, we have the Nawada canisters that hold the cartridge filters. We have Teflon gaskets for those. Because the Vitons, they just don't last as long as we want. And so Teflon can be a little trickier to work with because it is a harder material. It doesn't quite soft seal as well as some of the other ones, but it definitely does last a long time if you're careful with it when you're changing out the filters.
Well, we have for these gaskets, so that's one of the things that our service guys have. We have it in our inspection every time we go out there as part of our checklist, but every time we pop out, put in new filters, that is one of the things you need to observe is your gasket, making sure you got proper seal, there's no erosion, degradation over time. And if there is, of course, swap it out. So that is one of the lessons learned we got from managing our lease fleet. We do have one question that popped up while you were talking. It says, what about for the pressure for those kinds of materials? Is there a pressure difference that can affect them?
If it's designed to fit in there, so like a Buna O-ring on a vessel closure, is going to work for whatever pressure, unless the temperatures might be elevated. So if the temperatures are like 300 degrees and it was only designed for like 120, then you know, Buna may not be a good option for that. You may melt your O-ring within that vessel. So it kind of depends. Pressure should be fine as long as you're not looking at elevated temperatures. Then you'd want to look and see if it's the actual gasket on the filter. Pressure doesn't really matter because the differential that you're looking at for most filters is only going to be like 10 to 15 psi. So any of the material options are going to be sufficient choices. for that. But really, it's when your temperatures might be elevated that you want to really look into the pressure rating for them. But for like our seals, I mean, they work up to the rating of the housings. Like the housing's good, you know, at 125 psi up to 200 degrees, and we know that, you know, Buna is good for that, for the standard like T-handle closures. But yeah, that is something to look into if you have elevated temperatures.
All right, so getting from that, we went through the medium materials. Now we're going to go specifically into glycol and amine filtration. We got coalescing after this, but we wanted to go specifically go into this. So this is a typical amine PFD. So we got was it 5 major areas that filters are recommended to have. So you can kind of walk us through why these filters. I know we're going to touch specifically after this, so generally kind of go through this.
So for the first thing, before the amine and the glycol unit, both, I'd say a coalescing filter is a requirement. You can operate without it, but a coalescing filter will save you so much headache from having problems. Like a good coalescing filter ahead of that contact tower to remove the contaminants in there. And the farther away you are from the wellhead, the more chance there is of other things getting in there. So the compressor lube oils, if you're after, you know, major compression, surfactants that may make their way through separators, other production chemicals, methanol, all these things can cause problems. And so good coalescing filter ahead of the contactor will work. And the coalescing filter will also remove particulates. So keeping that out of your regeneration system will also extend the life of the filters that are on your regeneration system. So if your contact tower is removing all the particulates, you're just going to catch them in your little filters, and you're going to have to change those more often. But for a typical amine plant, then this is different people make amine plants different. The carbon filter is not always on the lean side or on the rich side. Sometimes it's on the lean side. But usually wherever the carbon filter is, you have a particulate filter before and after it. We like on the rich side to have a 75-25 micron particulate filter ahead of the carbon filter. Then you have your activated carbon filter. And then you have another particulate filter that's going to take it down to 20 to 10 micron. And so if you have a good 20 micron absolute rated filter, then that's sufficient. You don't necessarily need to go to 10 micron. The thing is, a lot of string wounds are called 10 micron filters, but they're not actually 10 micron filters. So it can be a little tricky. Sometimes it's better to upgrade, and because you know you're not going to get quite as good of a filter out of that. For what you're buying. The string wound filters, they're very easy to make, so a lot of different people make them. Even the big name manufacturers don't actually make them themselves, they sub that out. And so you're not always going to get maybe the same quality with a string wound, especially if you're changing vendors. Especially resellers may trade vendors and you don't even know, you're not even getting it from the same people. But a good 20 micron on an amine plant is going to make sure that you don't have a lot of problems going forward. And then another 20 to 10 micron particulate filter on the lean side, just to make sure nothing gets into your pump and continues into the contact tower and potentially fouls the contact tower.
That's on the amine, and then glycol PFD. A lot of it's pretty similar. I mean, both systems are pretty similar, but tell us what the differences are.
Yeah, so the main difference with the glycol unit is a lot of them are going to be smaller systems with a Chemray pump on them. I think it's very important. I mean, Chemray recommends a filter ahead of their pump. You just don't see them a lot, especially on smaller glycol systems. You don't see an inlet filter on the high pressure suction of that Chemray pump. But I think it's a very important thing. It should be at least a 75 micron. I think Chemray says it needs to be at least 100 micron or better, but really if you get to 75, then you're really helping out a lot. And then carbon filtration, I think, is also very important for glycol. Again, you really don't see it on the smaller units, but it is a very important thing to keep the smaller hydrocarbons, some of the chemical issues out of the system. And then it's also good to have particulate filtration after a carbon filter, because the carbon filter may have what they call carbon fines, which are very fine particulates, the carbon that break off. You don't want that ending up piling up in a reboiler or getting stuck in a heat exchanger. So it is good to have a particulate filter after that. And it's also good, like with this, you'd have a staged filter. You have a higher micron and you have a lower micron, which means that the higher micron is going to get the bigger stuff and the smaller one's going to get the smaller stuff. If you had the low micron on the beginning, you may have to change that filter more often, and then you never change the second one. So staging it out can help to extend the life of both of the filters to where, you know, you get 2 months where you change both of them instead of changing the lead one every 2 weeks. Because it's just getting so loaded up because it is such a smaller micron. So staging them out can help if you're having issues. And then also it's always good to have a lean side because of the regeneration. If you're getting a degradation product, like if you're overcooking your glycolamine and you're creating problems in there, or you get hydrocarbons in your reboiler and you're cooking that off and you're creating like a soot that can pile up, your reboiler regeneration side can create problems. So it is good to have lean filtration. Even if you have super great filtration on the rich side, you still need something on the lean side to protect your pump and to protect your contact tower.
Well, it's kind of going into, so in the beginning, we were talking about chemical compatibility, temperatures, first of all, identifying what do you have. So this first one is analysis and control of the glycol. So this is kind of us identifying what do we have in the system, and so that way we can match the correct filter to it. So explain to us, so you broke it up into 2 areas, field tests and lab tests.
Yeah, so analyzing the glycol, the amine can really give you a good idea of where your potential failures are in your filtration. If you're having issues or you don't like what you're seeing with the plant, you know, some field tests can really help out. So looking at the color of it is very important. The color can tell you, depending on the color, it can tell you what your contaminant is. If it's green, you have an iron oxide in there. If it's more of a brown, you have iron sulfide. If it's more of a brown, iron oxide in there. So that can kind of tell you what the issues you're having. So if you do have an iron sulfide is usually very small particulate. So you're going to need a good filter on that to be able to get that to remove out. You know, a quick foam test, shaking up a sample of the glycol to see if it's foaming will tell you if your carbon filter is doing what it's supposed to, or maybe you need to add a defoamer. And then testing the pH is very important, like we saw in the dehydration module. That's something, you know, Terry very big on. That is critical if you're trying to reduce corrosion in your system, in your glycol unit. So, you know, measuring pH every once in a while is a great idea. And then you can always send it off to a lab to get all this tested. Lab will tell you a lot more information. It can tell you solids, iron content, salt that may be coming in from the well, hydrocarbon in there. So it's a really good way to really see what exactly the contaminants are if you can send it off. And it's also good if you send off the lab samples to just have a baseline. If you do it once a year, twice a year, it's nice just to have a baseline to see if you can, you know, see if there's any trends that may be a cause for concern.
Now that's for glycol. So again, it's identifying the issues that's within the system. So on an amine, there is some slight differences. You still broke it up into field tests and lab tests, but tell us what the differences are for amine.
Yeah, so for amine, you're going to do the same thing. But for an amine plant, it is a lot more important that you maintain the quality of the liquid going through there. So you really want to make sure it is more important than a glycol system. Glycol systems are a little more forgiving. But for an amine, you really want the cleanest amine you can get. It just really will help you operationally. Because something we've seen in our plants that we operate is it can be fine up to a point, then all of a sudden you have a problem. And it takes a lot of effort to get it back to that point. So though it took 3 weeks to finally get to a point where you see the color getting darker and darker, and you know, but everything's still working okay, and you just keep accepting it. When it turns into now you have to fix it, it is a big hassle. So, you know, maintaining it and monitoring how things are looking is very important. For an amine plant, you're going to do a titration to see what your percent of amine to water is. Again, you know, pH, observe the color, observing the foam. You know, great foam test for the charcoal filters, test it before and after to see if it actually is doing anything. And then I think a lab test is something that should always be done for amine. You should, you know, maybe quarterly be sending away for lab samples just to make sure. With an amine plant, because of the corrosive nature of what you're removing from there, you could be slowly dissolving your plant. So it is good to really have an idea of what your baselines are. Are things getting worse? Are they getting better? And knowing how much, like you get a big upset, you know that you put in a bunch more water amine to make up for lost water. You know, knowing what that is and keeping good logs of all that is very important to make sure that it's working well.
Well, all right, so that's kind of identifying where we're at, so that way we can match up to the chemical compatibility, temperatures, everything of our system. So now we're kind of going into some quick recommendations. These are our quick lessons we learned over the years. So the first one was filter recommendation for a glycol system. So explain this quickly and then kind of go through, why.
Yeah. So the standard micron for glycol filtration is going to be like a 75, maybe 50 micron. That's usually what's going to come with a standard filter housing, and that you can live with that. That's you can get through most days with that. But if you can afford the 25 micron, keeping it 25 micron, you're going to extend the life of that plant. You're going to extend the life of the pumps, the valves, the controllers on that unit, and you're going to keep your glycol a lot cleaner. Clean glycol doesn't less likely to foam. It's less likely to need to be replaced. If it gets to such a bad condition that you have to swap the whole thing, that's very expensive, and who knows how much junk's been building up inside that system. So 25 micron, I mean, it should be what they call water white, where the glycol, it's got like a little of yellowish tint to it, but it needs to look clear. If it's foggy or anything like that, then upping the quality of the filtration. So string wound filters are going to be kind of like your standard base level filtration, but going to a nicer cotton filter or a better polyester filter, of a good pleated, well-made polyester filter, can give you really good dirt holding capacity and a true 20 to 25 micron absolute rating, instead of just like probably a 10 micron with a string wound, but more like a 50 micron.
All right, so that's kind of going down to a 25. So particulate filters for glycol systems is our second recommendation. So explain to us what you're looking for on that one.
Yeah, and so that I kind of covered in the other slide, but 25 microns kind of where you want to be with that. That is very important to make sure that you do have a good, an absolute 20 to 25 micron rating in there, because you don't want it building up on areas inside the system, because eventually it gets to the point where you have to, if you have to take a steel column off and change all the packing, it's a lot of work. It's a lot of cleaning, it's a lot of dirty work, and so it's going to shut things down for a good amount of time.
The big one on that one was people utilize, say, sock filters. I need a sock filter. Now, I know people use different terminology. So a sock filter is, I always picture just like a true sock filter, but what are they actually meaning? Because we like to say particulate filter. So explain that difference.
Yeah, so sock filter is a generic term. Like even those canister filters that are like the hard brown material, like people still call those sock filters too. I mean, a true sock filter is literally a tube sock looking material that's stretched over a frame. It's an old style design. They still have their use, but I think the name just kind of stuck. And a lot of times they're covered in a sock. Even the nicer ones are covered in what looks like a sock. But even though it is like a pleated filter or a depth filter, it's just covered in a sock to help with the drainage of the liquid. But really, yeah, for you want a good particulate filter meant for this service. Like what an actual sock filter isn't what's gonna help you out. But a good, like a pleated filter or a good string wound can really help to make sure that you keep all those little particulates out.
All right, so your other recommendation was activated carbon filters for glycol systems. So I know that was a big push. You kind of got excited about this one. So tell us, why were you excited about it?
So, carbon filters I think are very important. Typically, they're considered optional for like 500 MBTU regions and smaller. Really, a carbon filter should not really be optional in a glycol system. Yes, you can get away with it, but you're just, the cost, the added cost of that is usually equal to or less than the cost of swapping out all your glycol, even on a small unit. Once. And so if you don't have a charcoal filter, you're going to have to swap that glycol more often. It may be once a year, maybe twice, or every 2 years or 3 years, but eventually you're going to have to do it. Whereas if you just maintain the charcoal filter, you're not going to have to deal with that. The other big problem we see is that for the carbon filters, everyone likes to use those carbon canisters. They look like a big old paint can. They're either like a 7-inch or 11-inch diameter, and they're like 2 foot long. And they like them because they're easy to change. The problem with those is that the bigger 11-inch diameter one is only good for 1.3 GPM. That's about 80 GPH. So if you think of a Chemray pump, like a 90 GPH pump is the smaller ones for like a 200 regen. but you see 750 glycol units, 750 MBTU regens that do 450 GPH with that single canister carbon on them, and which means that that single canister carbon filter can only really be used in slipstream properly. You shouldn't do full stream with it because it's only good for 1.3 GPM, but that unit's running 7.5 GPM. So usually what we see is the carbon filters are undersized, and what means is you need to change them more often. They probably need to be changed to do what they're supposed to. They need to be changed on probably the same frequency as the particulate filters, which normally carbon filter you think you can get probably three times the length of time on them. They also, people put differential gauges on carbon filters, but they usually never show a differential. If they do show a differential, you need to change them immediately. They're not supposed to show any differential. It means that they're collecting particulates that it's not supposed to, it's not designed for, and it means other filters aren't doing what they're supposed to. But the carbon filters need to be changed on a schedule, or you need to be doing a foam test where you take a sample before and after the carbon filter and you shake them both up. And if there's a difference in the foam, then it means that that filter is working. If you shake them both up and they both have a head of foam that's not breaking down on top of them, it's the same height, that means that charcoal filter is not doing anything anymore. Usually if you're doing that foam test, you can use that to figure out when you need to change it, but it can be good just to change them on a schedule. But usually what we see is those charcoal filters are just, they're undersized from what they need to, and so they do need to be changed more often than probably typical recommendations.
Well, that your next one was bypassing safety, and I know this one because we had this issue when we first started off. You know, we were designing out there, we put out the filters, and then if you don't have a bypass to operationally bypass it so you can depressurize it, change out the filter, your service techs don't do it. They kind of pencil whip everything, which we found out when we started having, you know, a domino effect of troubleshooting calls afterwards. So now all of our systems have a built-in bypass ready to go, because if it's not operationally going to function for them, no one's going to do it. It's too much of a headache to shut down a pump and then have to re-kick everything back on.
Yeah, and this is something we see a lot on smaller glycol units. For some reason, manufacturers don't seem to like to put a bypass around the filter. A standard small glycol regen will only have a lean filter on it. I don't know why that became standard. It's a terrible idea. But for some reason, that seems to be the standard. The only filter they want to put on it is that one, and they don't put a bypass on it, which means you have to turn your pumps off, you have to block it in, you have to drain the liquid off that vessel, and the unit's just not pumping, which, you know, your reboiler, if you don't want to turn that off either, then, you know, temperatures are shut down and everything. But then you have to reestablish circulation. It can be a problem, especially, you know, if the operator is not that great at, you know, reestablishing circulation, making sure the pump's set rate, and knowing what that pump was set to, so you've optimized your glycol circulation. If they don't know how to do all that, you know, a bypass, you could send anybody to change a filter if it's got a bypass. You know, that's a lot easier to learn than learning how to properly start and stop circulation on a glycol unit, and then optimize that circulation rate for how much water you're removing. So, you know, it is important to be able to bypass that filter safely. And, you know, if you have a bypass, it means your guys aren't rushing. You know, if it has a differential, maybe you can bypass it for a day if you don't have the filter. So, you know, people aren't rushing around it, you know, because the unit's shut in. So bypass, if you ever get a glycol unit that doesn't have a bypass around, like the little filters, just put one in before they install the unit. Just have the same guys installing it. It just saves you a lot of trouble and headache, because the guys won't change them. They'll change it when the unit shuts down for some other reason, like when the pumps fail because they're not getting filtered properly.
That's right. Yeah. So whenever thing shuts down, that's when they'll change it. The other one was filters for rich and lean side. So I know you're a big proponent, like you were saying earlier, you usually get filters only on the lean side for some reason. So you and Terry are real big on filters on the rich and lean side. So kind of go into that why.
Yeah, so the filters on the rich side, that's going to be filtering the stuff that's coming in that the glycol or amine has been able to wash out of the gas stream, and so that's contaminants coming in from the gas stream system. Your filter on their lean side is going to be stuff that may have been created within the reboiler. So they both serve different purposes that are important. So it is really good to have both of them. You know, the lean side, it also is protecting your pumps, but it's also protecting your heat exchangers, you know, fouling your contact tower, any other controllers that you may have through there. So it is important to have it on both sides. And like I was saying when we showed the PFD for the glycol unit, having it before that Kimray pump, a high pressure canister filter before that Kimray pump to help protect that pump. Because if you get sand into that thing, you're going to scratch those cylinders within that pump. That pump may start bypassing if you cut those seals, and then the pump isn't going to hold its speed, or you're going to have to change it, or rebuild it more often, which can get expensive compared to the cost of a filter. We had those little ones that they cost like $15. That saves you on a bigger pump. In exchange here in the States, it's going to cost you $3,000 to exchange a 450 pump. Take the broken one, give it to them, get a rebuilt one, compared to a $15 filter that would have saved you that. That's a big cost savings.
Well, one of your last ones was improved filtration, was observe the filter use. Now, you said that earlier of kind of like a step down on the filter side. So where we tell our service guys, pull it out, cut it in half, look at it, and then explain to us why cutting it in half. What are you looking for?
So as you can kind of see in the picture, the dirt loadings all happen on the surface of the filter. So for this particular filter, if it was showing differential to where you had to change it out, then this filter wasn't being used to its capacity that it could have. So if for this is your problem, if you're changing a filter and it looks like this every week or every month or something, if you would put a higher micron filter ahead of it, then this filter will last much longer, and that other filter should last longer as well, because it's staging it out and you're getting the optimum use out of both filters instead of this happening more often. So if that's something that you're seeing, it's not always strictly looking at differential isn't always the best option for changing your filters, especially like with coalescing filters. It's definitely not, because if you collapse a filter, then there is no differential and you think your filter's clean, but it's just been destroyed. So it is good to actually look at the filters, see how they are collecting, to make sure that you do have the right filter choice in there for what you're using.
So on your last one was a foam test for activated carbon. I know you've been touching on it several times and you're very excited about activated carbon. So explain to us on that for the foam test.
Yeah, so the foam test is super easy. You just take 2 samples before and after the carbon filter, you shake them up, and you examine the foam head that sits on top of those samples. So it's obviously going to foam if you shake it up. If it all breaks away pretty quick, then you're fine. If you have a steady foam on top of your inlet sample, but your outlet sample there's no foam, then your carbon filter is working great. But if you're doing this test often enough, you can actually see when the carbon filter is no longer doing what it's supposed to, because the foam on the outlet will get more and more and more. So making sure that that is working, it's a really quick way to check to see if that carbon filter is still working for you.
All right, so that's amine and glycol. So now we're going into coalescing filters, focused on that. So again, foundation steps, kind of go through us on what is a coalescing gas separator? What is the goal of it?
So coalescing filters are for use after your separator. So your separator is going to get you down to about 10 micron. Coalescing filter is what can actually get you down to 0.1 micron with a good enough coalescing filter. But they're gas filtration for removing out the stuff that the separators aren't quite getting.
Now, that was actually back to one of the questions. Someone asked, in gas processing, we use wire mesh for filtration. I think he's talking about the I guess the mist pad on a mechanical separator. So you're saying if that's the case, you would put a coalescing filter outside or downstream of a mechanical filter or wire mesh? Is that what you mean?
Yeah. So I mean, it could be like a strainer. Strainers, you can get strainers down to I think 50 micron. With a strainer, strainers just really, they don't have a lot of dirt holding capacity. So if they get hit with junk, they're gonna block up pretty quick, because it is just like that single layer mesh.
Okay.
Sometimes you have like, they call it witch's hat. I mean, that's what the field guys like to call it. It's just for catching cats and dogs that may be coming through the pipe. So that's usually used like before a compressor, just so the big rocks that may have made its way into the pipe don't end up slamming into a compressor valve.
We say cats or dogs, but Terry actually said that when they were doing a startup coming into the system, they actually got a jackrabbit that was shoved into. So it does catch cat, cats and dogs.
Well, I mean, we've pulled rocks out of it, and like you see, like the new guy grabs it, and he's just like, "Did this come from the well?" And it's like, "No, of course not." It came from when they threw the pipe in the trench, dragged it 10 feet to line up with the other pipe, and scooped up a bunch of rocks into the pipe. Like, you're not having pebbles coming up with the oil and gas. But yeah, I mean, it could be a problem. But yeah, strainers are great for that sort of stuff. Strainers are good. They're good pump protection as well. If you can't put a filter in, a strainer is a good option. They're good to help heat exchangers. If you have like real small tube heat exchanger, strainers are really good options for liquid service, just to help protect that. And they make good pre-filters before, an actual filter, just to make sure the big stuff's gone.
Well, and that's what you want to split up again. What is a filter separator versus a coalescer? Because we get, when the client's talking with us, they kind of use it synonymously, they just throw it out there, but it is two different things. So explain what the differences are.
Yeah, so filter separators are usually filters that'll take you down to around 1 micron, but they're really meant for particulate removal and maybe a little coalescing. But really, they're meant for particulate removal. Versus a coalescer is specifically designed to coalesce the liquids out of the gas. So that's your aerosols, your mist, your fog. That maybe when you get condensate creating it, the condensate's going to condense on the sides of the pipe, but you can also get a fog of that condensate condensing mid gas stream. So you just have this fog that's floating through the gas stream. To get that out, it is tricky because it is light. It can be tricky to remove. So removing it with a coalescing filter is the best way to get that out of there. But it is two different types of filters for that, and it can also change the configuration of the vessels.
All right, so now vertical and horizontal. I know on a lot of our fleet we use horizontal filters, but explain the differences and advantages of the different ones.
So horizontal is usually going to be your filter separator. That's the common design for that. Some vendors, some of the manufacturers like Pico makes a horizontal that is a coalescing filter. But typically your horizontals are going to be a filter separator. It's usually an outside to inside flow. That means when you open the big hatch and you're looking at your filters, that's your dirty side. That's your gas inside of things. So you may actually get dirt where you can actually pull it out when it falls off the filter. But that's usually filter separators. Vertical vessels, that's more likely going to be a coalescing filter. Your best high efficiency coalescing filters are almost always going to be vertical configurations where it's an inside to outside flow on that filter. Where the gas comes in, and when you open the hatch and you're looking at it, you're looking at the outlet side of the filters. The gas comes in through the middle and goes out through them. And those are best for coalescing for configuration reasons. But usually the best coalescing filters are vertical configurations.
Good. And then pleated style filters. Now you're going kind of into specific into, I guess, like what we did on the other ones, the medium materials or what we utilize. So yeah, explain pleated.
Yeah, so pleated, like the JPMG or PSFG style filters from your Pico and your Jonels, those can get you down to 0.5 micron, but these are really good for high particulate holding. So they're going to hold a lot of dirt because of that shape. The dirt can fall in the grooves, but you still have some open area for the gas to flow through. There's flat material that's been folded into this pleat and then wrapped into the cylinder. They're really good for particulate holding. They can do some coalescing, but they are good for if you do have a lot of particulates you're trying to remove. They're a really good option for that.
And your second one was depth style filters. So kind of go into that. I think we use the picture on the left-hand side, we utilize that one a lot, right?
We do, yeah. The JFG or FG model filters, like if it says that, then it's got a bunch of numbers after it. Those are like the workhorse of the industry for coalescing filters, filter separators. A lot of people use them. Jonel and Pico sell a ton of those things. They can get you down to 1 micron. They can do some coalescing. They can also catch particulates on the outside. But these are meant more for a good mix of both coalescing and particulate holding. And it's just a thick pad of that fiber material that the gas has to go through. So the gas has to wiggle through all those different fibers, and the effect of having to do all that torturous path can help to knock stuff out of the gas stream and coalesce particulates.
All right, so what makes advanced depth style filters advanced?
So for like the highest end of the coalescing filters, the fiber is actually, it's a different shape. It's not round. And then it goes into the quality control too. It's like the thickness of the material, the effectiveness of it. So these coalescing filters, these are the ones that get you down to zero.1 micron. In them. They're usually like the one pictured there, that's a reverse flow, which means an inside out flow, vertical configuration filter. So if you put it in the right vessel, you put that filter in there, you can get down to 0.1 micron on your outlet. These are really good for difficult to remove liquids. So like your high detergent compressor oil, your low surface tension liquids, the stuff that's going to shear really easily, that doesn't stick to things very well, it doesn't fall off of something, those you need this more advanced filter to be able to remove that. High detergent compressor lube oil can cause all sorts of problems. I know we see it all the time with our dehighs. They cause foaming inside contact towers. You need a nicer filter to be able to remove those. And these advanced ones are really the only way to do that effectively.
All right, and your quick recommendation for coalescing separators, explain to us why.
So on the differential gauge, the cheaper differential gauges do not have the little follower needle. I think it's always great to have that follower needle, especially on coalescing filters, because what it does is whatever the highest that sees, it will stay there. Even if the needle drops back down, it'll stay there at whatever the highest one was. Which if you look at it and you see it went up to 20, but it's not there anymore, there's a good chance that filter's collapsed. So I think, just adding that, it is a little more expensive to pay for it, but it's a really good way, especially if you have changing pressures or volumes, to see if, if it did get to the point where it needs to change. A lot of the wells that we're seeing, especially in the shale fields, they're starting to decline. Equipment's maybe a little oversized than it was. A lot of wells are getting put on intermittent flow or plunger lift operations, which gives you erratic flow. And if you're looking at it when it's flowing 100 MCF, but it spikes at 1 million, but you were never there for it, you don't know if that filter is actually time to be changed or not. So that's a really cheap little option that can give you a little more insight into operations.
All right, so we're going to wrap this up. We got 5 case studies that reaffirm kind of our lessons learned on this. So we're going to go through these pretty quickly. But case study number 1, Amine filter. What happened?
Yeah. So this doesn't have anything to do with the filters. This was the wrong defoamer. So as you can see what it does to your filters, that's why it's good to have a differential gauge on all your filters. This defoamer was a silicon based, which is now what you're supposed to use for amine. The company guy had some defoamer left over, and so instead of our service guy using what we normally get because he didn't have it on his truck, he grabbed what the field guy gave him because it was free, and we ended up with about a week worth of headache trying to get this out of our system. But yeah, this is, making sure things are compatible. This also goes back to chemical compatibility, making sure that things are compatible with what they're supposed to. This defoamer obviously wasn't compatible with amine, and so it gummed up the filters pretty good.
So this actually should be not a case study, but a case study of why you change filters and have good filters. And
yeah. It's good to have differential gauges to tell you when this happens, because these run the smaller Nawada cartridges, and to add a differential to that, you have to like pipe it in, and so it takes a little more effort to put a differential gauge on those kind of canisters, but it's worth it because you see things like this immediately. You're not wondering why your pump's not stroking, thinking the pump's broken, when really your filters are so clogged you can't even run your pump.
That's right. So case study number 2, this goes back into your needle gauge follower you were talking about earlier, but what happened here?
So this one got slugged with a lot of mud and rocks because of like I mentioned earlier, a bad pipe install. They got a bunch of mud into the pipe. When they ramped up, initially the startup went fine, but when they ramped up to full volume, it dislodged it and then relodged it into our filter. And so like once you actually started washing it off, you could see that the brownness of the mud and all the rocks and everything in it. But yeah, this is because it was collapsed, it wasn't showing a differential, because it broke off the back end of it. This one, it's stretched because they've tried to pull it out and it's so jammed on the holder. But this is a really good reason why you should change your filters. And also, filters, it's good to have a separator ahead of things. This one didn't. And so the slug section on this wasn't able to handle it. But it is good to have, an initial slug, separator ahead of a filter. It'll give you more life out of your filters and make them last longer.
Mm-hmm. Case study number 3, wrong filter choice. We spent half the thing talking about filter choices and identifying what you have in the system. So now, walk us through the issue and the solution on this one.
So yeah, this was a string wound filter that was not the right material. So you can get string wounds in other materials. They can, not just cotton, you can get them in stronger materials. And this one was not the right one. You can see all the strings have broken apart. It looks like they started to fall over within the actual vessel and created quite the mess to have to clean up. So this is really why the material, just because you use it in glycol, does not mean it can work in amine service. Even if it takes like the exact same size filter, some of them you can, but not all of them. You can't just swap them back and forth. So this is why it's really good to check the chemical compatibility with your filters.
All right, case study number 4, deficient amine filter design. Walk through this one.
So these look like good filters. These look like higher quality polypropylene filters. I'm guessing from the white material of it, and they have a nice big vessel, so this would have been a fairly large amine plant. But what they didn't account for was the temperature that these were going to be into. So as you can see, the temperature of the hot liquid coming in has melted these filters to where they're probably falling off their seals on the bottom, and they're probably melting together to where they're not actually filtering like they're supposed to. So this was somebody didn't check what the operating temperatures were going to be, probably in a worst case scenario, and what happens when that operating temperature gets out, beyond what it's supposed to. Amine plants usually operate a little hotter than glycol units. You have a heater reaction in the contact tower that brings a lot of heat back into the system from the contact tower. So on a rich filter, you can easily melt things. Especially if you're hitting like 140, 150 degree temperatures, if you're, getting close to what that max operating is for those materials. On the lean side, you have an exchanger issue, or somebody bypasses an exchanger, then you can melt your filters. But yeah, this was, not checking temperatures, and not knowing what those temperatures could be for this plant.
All right, this last case study, you were really pushing on carbon filters earlier, and this is kind of explaining why we need to have proper carbon filters. So explain what happened here, what these 3 pictures are.
So this is all from the same plants. And so this unit did not have carbon filtration, and the residue of which would have been removed by the carbon filter has ended up all throughout this plant. So you can see in the left picture, those are the bubble cap trays. They have residue all over it. What typically happens is in the reboiler, you get like this cooking action. It can actually sort of combust the hydrocarbons, which actually burns them, and then you get this degradation product, and you can burn some of the glycol too, but you get like this soot or a coke type material that can end up in places it shouldn't. So it's ended up all over the bubble cap trays, and it's completely started to coat the packing to where it's actually looks like it's impacting the gas flow through that packing. The center picture is the metal pawl rings, and they're completely coated with this black soot material. And then the heat exchanger, has this sludge material. Like I said, high temperatures that particulates can mix with the liquids, and they can turn into a sludge. And so they have this slime that's impacting their shell and tube heat exchanger. And so, a good, particulate filtration would have helped this as well, but carbon filtration would have kept it from getting this batted.
Well, that ends the case studies. So quickly, we got a Q&A section at the end, but we do have an upcoming webinar that's coming. It's a production and processing roundtable. So I am really excited about this. We're actually having Chris come back. We're having Terry Nelson with Waukesha Pierce speaking with us. And then we have Jesse Oliveras with O Synergy. So how this one's gonna be a little bit different. We're opening up the platform. Anyone can ask any questions about processing, filters, JTs, dehydration, anything kind of going in the line. And then now we got these 3 subject matter experts that will be giving their best recommendations. We'll have some reference materials, but we're really opening it up to anyone that can ask these type of questions. So that's in 2 weeks. if you got some pre-questions, you can't attend, but you have some questions, to submit it to us, so that way we can make sure that those are addressed to these three subject matter experts. Now, if you're interested in being a webinar speaker, or if you know of someone, please let us know. We want to reach out to tori.valagura@croftsystems.net, so that way we can get them coming on board, sharing that knowledge. You will get a survey at the end of this. Again, I'm Black Belt Six Sigma, so I love continuous improvement. I love data. So the only way we can get better is actually by y'all filling out the survey. From the last survey, it actually helped us a lot. People wanted more open platform questions, and that's why we came up with the roundtable discussion, just opening up to just answering questions. And I think that's going to go over very well. So the Q&A section right now, we did have a couple questions through the presentation. I don't see any new ones right now. But again, if you don't have them now, you get them back out to your field. One of our other companies we have is Croft Supply. It's an online e-commerce. You can order all the filters through there. If you have any particular questions, things that are happening, please reach out to us. We're here for you. We'll let you know about our best recommendations of chemical compatibility, what might work, or if anything, we can just probably spitball some ideas for you. So I don't see any questions, so we're going to kind of end this webinar. But again, reach out to us if you have any questions specifically about your projects, equipment that you're dealing with right now. But I appreciate it. All right. Thank you, guys. All right, let's go to lunch, right? All right.